Okay, let's try this, like, take number 3. Okay, guys, I'm sick. I was going to cancel class on Tuesday. If we were, like, still meeting in class, I would have canceled, and I rarely cancel class. Like, I think I've canceled class once, and that was because I was in a wreck on the way to school. Yeah, someone slammed their brakes on in front of me, and I just plowed into them because I was in my truck, and my truck's brakes are not the best. And I wasn't even following closely. They just literally slammed on their brakes. It was insane. So watch out for people slamming on their brakes. It was nuts. But yeah, so I really don't feel good. This is take number, I don't even know, 4, I think I said. And my throat is about to, like, yeah. I'm trying not to cough. Yay! So what I want to say, I already have stuff written because it's, again, my 4th take or so. But we have 2 boxes, and what's in these boxes are basically different ways of saying the same exact thing, okay? So on this one, x equals c is a 0 of some function, and we'll call the function g of x. And what does that mean? So 0 is not a new word for us, but maybe it is. A 0 or a root, those are the same word, just different spellings of the same word, right? Like it's English and Spanish. So you have blue and azul, right? Same thing. So x equals c is a 0 of the function g of x. And what that means is if you plug in c, you'll get back 0. You plug in c into your function, and you get back 0. So you have your function g of x. If we plug c in, what is c? Why c? Because c is the 0. So if we plug c in, we get back 0, okay? So how that helps us is if we're trying to find a 0, it means set your function equal to 0 and solve for x, right? G of x equals 0. So if g of x equals 0, solve for x, and you'll find out what that number c is. Now, what I've written down here, if, right? The if with an extra f is if and only if. If and only if. And what that means is when this box, when a statement is equal to another statement, right, you have a double arrow, okay? You have an equal sign that's a double arrow. And it means that if this side is true, then that means this side is true. And if this side is true, that means that this side is true. And you'll notice that's not always the same, right? So like, darn it, I forgot to grab my sticky notes, but I thought about something. How can I explain this? So I won $13 million in the lottery. That implies now I have a lot of money, right? That's true. If I check the box that says pay out now and they send you a check for, okay, well, I guess it'd be 13 million minus the 30%, 40% of taxes or whatever. But anyways, if you win millions of dollars in the lottery, then you have a lot of money. Is the reverse true? So this side's true, but is the opposite way true? I have a lot of money. Does that mean that I won 13 million in the lottery? No, right? I could have money from oil. I could have money because I'm conquered a get-rich-quick scheme, like some MLM marketing stuff. I aced that stuff, and bam, now I got a lot of money momentarily. Or maybe I have old money, meaning my parents had money, their parents had money, and it's just been passed down to me. Something like that, right? So just because one side implies the next does not mean the reverse is true, right? So this is an if, then, and you can't just reverse it. It's not an if, then. You can't reverse it. So one way might be true, but the other way might not be. But here, on an if and only if, one way is true, this side implies that side, and the other way is true. This side implies that side, okay? And that's why you have a double arrow. And that double arrow is if and only if. Okay, So let's look at this next function. So last time we had 3 functions we were looking at. Last video. Anyways, we had 3 functions we were looking at, and we looked at x squared minus 9 last time. X squared minus 9 factors into x plus 3 times x minus 3, giving us a root of x equals negative 3 and x equals positive 3. And those roots are x-intercepts because they are real numbers. So now let's look at our function, x minus 3 quantity squared, and let's see what those roots are. Or zeros. So in order to calculate the zeros, you set your y value equal to 0. Notice I said y value equal to 0, but I wrote g of x equals 0. It's the same thing, right? G of x equals y. Those two equal each other. So we set it equal to 0. So I'm going to come over here. 0 equals x minus 3 quantity squared. How do you solve this? If you did not have the minus 3 there, you'd have x squared. When you have x squared equals a number, we just take the square root of both sides, right? So that's what we're going to do. We're going to take the square root of both sides. Square root of both sides. And when you take the square root of both sides, we have to have a plus or minus. So we take the square root. And on this side, we have the square root of 0, which is 0, right? And plus or minus 0 doesn't make sense. You don't have positive 0, negative 0. So that doesn't make sense here, so we're just going to cross it out. Now, your square root of x minus 3 squared, the squared and the square root will cancel, leaving you x minus 3. How do you solve that? Add 3 to both sides. So you get 3 equals x. So you only get one answer. You only get one solution. So we did see this in class. And we said that when you have one solution on a function like this, it's actually called a double root. Nolan is coming back. They were playing on the trailer. So it's called a double root. Another way of saying it is g of x has a 0 of x equals 3 with multiplicity 2. And the multiplicity of 2 has to do with the fact that your g of x is x minus 3 quantity squared, and that squared is the multiplicity of 2. Okay, so you can ask, why is it multiplicity of 2? Where is this coming from? Well, what is x minus 3 squared? X minus 3 squared means you write x minus 3 2 times. So we would write x minus 3 2 times. X minus 3, x minus 3. So if we were solving the zeros of this, we would put 0 equals this times that, right? And what do you do when you have a factor times a factor? You set each factor equal to 0. Set each factor equal to 0. We would set each factor equal to 0. And what happens? We add 3, we add 3. We get x equals 3 for both of them. So we get x equals 3 2 times. Multiplicity 2. X equals 3 2 times. Okay? So we get 2 zeros, but they're the same zeros. So you say there's a 0 of x equals 3 with multiplicity 2. So with multiplicity 2 is kind of like a background thing. It's like if you're asking for the zeros, well, the zeros are blah, 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 blah. And then if you want to say one is multiplicity 2, you can, but you don't have to. So g of x has a 0 of x equals 3. Okay, now what did we see last time? Last time we saw that real zeros are x-intercepts. So we can graph this. So let's go ahead and graph. Let's do it this way. So we have over 1, 2, 3, 4, 5, 6. Might as well. So there's my x, there's my y. So I have x equals 3 as an x-intercept, right? And then what? How do I graph it? Let's go back to the function. Let's think about transformations. I'm going to grab a different color pen. Think about transformations. We have g of x equals x minus 3 squared. What do you see? I see minus 3 on the inside, right? This minus 3 is on the inside. And what does that say? That says it's a shift in the x direction. Since it's by the x, right? It's my x minus 3. Since it's by the x, it's not towards the negative side, but it'll be towards the positive side. Because remember, x's lies, by 3 units. Because x's lie, so you would think negative, so it's going to shift to the negative side, but it's not. It's going to shift to the positive side. So we're going to shift to the right by 3 units. So we take our parabola and we shift it to the right by 3 units. So our vertex was here, and now it shifted to the right by 3 units. Are there any other transformations? So we look at our function. Are there any other transformations? All I see is x minus 3 quantity squared. No other transformations. So that's it. That's it. That's your function. So your function is a parabola that was shifted over by 3 units. And that's it. There's your graph. So if you wanted to ask what is your range would be y is greater than or equal to 0, which would be starting at 0 all the way up to positive infinity. I just threw that in there to remind you. Okay, b squared minus 4ac. I knew I forgot something. B squared minus 4ac. So I'm going to draw a line. Horrible line. B squared minus 4ac. What is b? What is a? What is c? Well, I look at this and go, a is 1. But what is b? What is c? I don't know. So we need to multiply that out. So we multiply that out. I'm going to go ahead and put that up here. If I multiply that out, it's x minus 3 times x minus 3, right? X minus 3 times x minus 3. You distribute your x, distribute your negative 3, and you get x squared minus 3x plus 9. So that's x squared minus 6x plus 9. So my a is 1, my b is negative 6, and my c is 9. So I plug those numbers in. Negative 6 squared minus 4ac. Okay? So I plug those numbers in, and when I see this, I go, okay, negative 6 squared is positive 36. Negative 4 times 1 times 9, 4 times 9 is 36, and it stays negative, so negative 36. 36 minus 36 is 0. It's 0. So when your discriminant's 0, what does that mean for your quadratic formula? Your quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So what does that mean? That means you have, let's do it for this particular example, negative b, so negative 6 is a positive 6, plus or minus the square root of 0 over 2a, 2 times 1 is 2. When your discriminant is 0, you're not adding and subtracting anything. So how many solutions do you have? 1. You only have one solution.